Hi guys, and welcome to your final YouTube video for the year. Today we are going to go ahead and review for our conic sections test. We will look at all four conic sections: the circle, the parabola, the hyperbola, and the ellipse. We'll graph all four types of conic sections. We will look at their equations, and basically I'm going to make sure you are ready to rock the conic sections test tomorrow. So let's get going. The first conic section, this is the equation of a circle. And what we did yesterday is you made a really cool cheat sheet. Now this is something that you want to keep beside you today, as well as go ahead and use when you are doing the test. So the first one is a circle. So remember, the equation of a circle is x minus h quantity squared plus y minus k quantity squared. That equals the radius squared. The definition of a circle is all of the points are coplanar with the center. The center to any point on the circle is called the radius. Using the equation, the center is hk because it's a minus sign in the formula. The x value for the center is whatever you're subtracting from x. The y value for the center is whatever you are subtracting from y. Now your radius, in the equation, this is radius squared. So to solve for just r, you have to take the square root. So let's go ahead and do this. So the center, what are you subtracting from x? 5. What are you subtracting from y? Negative 3. So the center, I go to the right 5 and down 3. Now the radius, remember the radius is the distance from the center point to any point on the circle. This is r squared. So r squared equals 9. If I want to know the radius, you'd have to take the square root because a square root cancels the power of 2, leaving you with just r. The square root of 9 is 3. So to graph it, I can go from the center and go up 1, 2, 3. I can go to the right 1, 2, 3, down 1, 2, 3, left 1, 2, 3. Connect your outer points and you are done. So there is a review of how to basically dissect the equation of a circle, identify the center, find the radius, use that information to graph. Other things that we did for the circle. It just says if they give you information, can you go in reverse? So can you find the equation of a circle? This is called standard form. If the center is 0, 8 and the radius is 5. So it's x minus the x value from the center, that's 0, quantity squared, plus y minus the y value of the center, quantity squared, equals the radius squared. Now if you left it like that, I'm totally fine with that. Typically what happens, or what you would have saw on your worksheets that you work through, because this is x minus 0 quantity squared, they would have just had x squared. Plus, this is y minus 8 squared. 5 squared is 25. But again, I would be thrilled to have either of these answers written down on your test. Okay, let's look at one more. This time they gave us the center and they gave us a point on the circle. What we're missing is the radius. So in order to find the radius, you have to find the distance between the center and a point on the circle. Distance formula. You take the second x, negative 1, minus the first x, negative 4, quantity squared, plus the second y, negative 1, minus the first y, negative 3, quantity squared, and that is all underneath the radical symbol. So distance formula from geometry. Minus a negative, this becomes a plus. Negative 1 plus 4 is 3. 3 squared is 9. Plus, if I minus a negative, this becomes a plus. Negative 1 plus 3 is 2. 2 squared is 4. 9 plus 4 is 13. 13 is a prime number, so I cannot break it down. This is your radius. So now I have the center and the radius. I can go ahead and fill in the equation. So it's x minus the x value from the center, so negative 4, quantity squared, plus y minus the y value, negative 3, quantity squared, equals the radius squared. So what I did is I just filled everything in because it is a review. I don't want to skip any steps. So here for my final equation, minus a negative, you'll show that as a plus. So it's y plus 4 quantity squared plus minus a negative y plus 3 quantity squared equals, if you square a square root, it cancels. There is your equation. Oh, sorry, that's a 13. I didn't realize it was cut off. Okay, so this is a good review. If you understood how to do the distance formula, how to be given a center and a radius and write an equation. If you're given an equation, can you identify center and radius and graph? You are totally good for the conic section that is called the circle. Let's go ahead and look at the ellipse. Okay, now the ellipse, really cool. When I go ahead and look at my little cheat sheet, one thing you want to notice is that it's always two fractions with a plus sign in between. They have to be equal to 1. Now A has to be greater than B. So in order to figure out your vertices, you go with the greatest denominator. Okay, so that's kind of the difference between the ellipse and the hyperbola. When it's the ellipse, it's important that A, so the first denominator, is the larger of the two. Okay, so let's go ahead and do a couple of those. Now this one is ready to go. It is two fractions. There is a plus sign in between. It is equal to 1. To find the center of your ellipse, you go ahead and say, what are you subtracting from x? What are you subtracting from y? Nothing on either, so that means the center is going to be at 0, 0. Now your vertices, you have to know if your ellipse is going to be vertical or horizontal. So with the ellipse, it's the biggest denominator is 25. The variable on top of that is the x, so it's horizontal. Now you always have to know what is A, what is B, what is C. A, in this case, must be the biggest denominator. The square root of 25 is 5. So in order to find the vertices, I can do that already. I know it's horizontal, meaning I'm changing the x's. And what you do is add and subtract the value of A to the x value from the center. So 0 plus 5 is 5, so it's 5, 0, and negative 5, 0. So I go to the right 5, stay at 0, left 5, stay at 0, so I have my vertices. Now your co-vertices are based off of B. B is the square root of the smaller denominator, which is a 3. Because the vertices were x, the co-vertices, I changed the y. Again, you go back to the center. The center was 0, 0. To find your co-vertices, you add and subtract 3 to the y. So 0, 3, 0, negative 3. So 0 go up 3, 0 go down 3. Already I can connect and make the ellipse. But one thing that we don't have yet, we need the two focus points. And your focus points go inside of the ellipse. In order to find C, it is C squared equals A squared minus B squared. That's the relationship to find C when you're dealing with the ellipse. So C squared equals A squared is 25 minus B squared is 9. So C squared is 25 minus 9 is 16. Now that's C squared. I want to know C because C is how you find your foci points. The square root of 16 is 4. Your foci points always go with the vertices. So your vertices, you changed x. Foci points, you also change x. So I take the center and I have to add and subtract 4. So 0 plus 4 is 4, 0. 0 minus 4 is negative 4, 0. So I go to the right 4, stay at 0. Go to the left 4, stay at 0. And we are done. There is a horizontal ellipse. Now the next one. You will notice it is not equal to 1. So step 1, what we need to do is divide every single piece by 36 because the standard equation for an ellipse, you have to have it equal to 1 every single time. So here is your standard equation, x plus 1 quantity squared over 36 plus 4 over 36. That can be simplified to 1 over 9. 36 over 36 is 1. Now again, I have my two fractions. I have a plus sign, so I know it's an ellipse. It's equal to 1. To see if it's horizontal or vertical, you look at the largest denominator. The largest denominator is 36. The variable above the largest denominator is x, so it's horizontal again. So now let's go ahead and go for this. Center, what are you subtracting from x? -1. What are you subtracting from y? 3. So I go to the left one, up 3. That is going to be the center of my ellipse. Now vertices, because it's horizontal, I change the x. The way you change the x is you add and subtract a. A is the square root of the largest denominator. The square root of 36 is 6. So I have to go ahead and take the x value. So -1 plus 6 is 5. Keep the 3 the same. -1 minus 6 is -7. Keep the y value the same. So I'm going to go ahead. I go to the right 5 up 3. And I go to the left 7 up 3. Those are my vertices. Now to find your co-vertices. Because the vertices, we change the x. The co-vertices, you change the y. In order to find co-vertices, you use the b value. B is the square root of the smaller denominator. The square root of 9 is 3. So I have to take the y value from the center and add and subtract 3 to the y. So the x stays -1. If I add 3, 3 plus 3 is 6. Now for the second point, I have -1. I keep the x the same. 3 minus 3 is 0. So I go to the left one, up 6. Go to the left one, stay at 0. Once you have your vertices and your co-vertices, you can graph the ellipse. All we have left to do is find the foci points and make sure those foci points are side to side because it's horizontal and they must be inside of the ellipse. The relationship is c squared equals a squared minus b squared. So c squared equals a is 6, 6 squared is 36, minus b is 3, 3 squared is 9. So c squared equals 27. That is not a perfect square root. Because I'm graphing, I want the decimal representation. If I take the square root of 27 and I round it to the 10th, it's 5.2. Now to find your foci, your focus points, it always goes with the same variable as the vertices. So my vertices, I change the x. So the foci points, I also change the x. So you start with the center. -1 plus 5.2, well, that's 4.2. Keep the y the same. -1 minus 5.2 is -6.2. Keep the y the same. So I go to the right 4.2 and I go up 3. Perfect. It is inside of the ellipse. Go to the left 6 and a little bit more, up 3. Again, they are side to side next to the vertices inside of the ellipse. Here is a wonderful review of how the ellipse works. Now let's go ahead and go to the hyperbola. Now the hyperbola, it is created by having two, they call them branches. Basically, I've always said, hey, it's two parabolas, okay? But technically, it's branches. Now the hyperbola can be vertical, meaning the branches open up and down, or horizontal, meaning they open left and right. But again, you need to have two fractions. This time it's a minus in between. It has to equal 1. So step 1 here for this hyperbola is I have to go ahead and divide everything by 36 because I need this to be a 1. 4 over 36 is the same as 1 over 9. So it's x minus 1 squared over 9 minus. 9 over 36 can be reduced to 1/4. So it's y plus 2 squared over 4 equals 36 over 36 is a 1. Now, when you are dealing with the hyperbola, it does not matter which denominator is bigger. What matters is that your minus is in between the two fractions. The first fraction, that tells you if it's vertical or horizontal. This is an x, so it's horizontal. Okay. The first fraction, this is going to get us or help us to identify A. The second fraction helps us identify B. It does not matter which one is larger. Okay, let's go ahead and do this. Center, what are you subtracting from x? 1. What are you subtracting from y? -2. So right 1, down 2. Vertices, it's horizontal, so I have to change the x value from the center. You do that by adding and subtracting a. With the hyperbola, a is the square root of the first denominator. The square root of 9 is 3. So if I take 1 plus 3, it's 4, -2. If I take the x value, 1 minus 3, it's -2. And again, we're keeping the y the same. We're only changing the x. So I go to the right 4, down 2. I go to the left 2, down 2. Now your co-vertices, because I changed x for the vertices, you're changing y for the co-vertices. I need to know the value of b. b is the square root of the second fraction. The square root of 4 is 2. So I'm going to take the center. I keep the x the same this time. Now I take the y. -2 plus 2 is 0. -2 minus 2 is -4. Those are your co-vertices. Go to the right one, stay at 0. Go to the right one, down 4. This is enough to make my fundamental rectangle. Remember when you have the hyperbola, what you do is you take your vertices and your co-vertices and you use them to make what's called the fundamental rectangle. So it's a rectangle around that center. Now you go from corner to corner through the center, and these are called asymptotes. What they do for you is allow you to see how wide or how narrow the branches are going to be for your hyperbola, okay? Now I need to find the foci. Here, your foci points need to be outside of the rectangle because when you draw the branches, you're going to hug that focus point, okay? C squared equals a squared plus b squared. Notice it is a little bit, well, there's only one difference. This time it's a plus instead of a minus. It's a different relationship when we're dealing with the hyperbola versus the ellipse. So c squared equals a squared, 3 squared is 9, plus b squared, 2 squared is 4. So c squared equals 13. If I take the square root, it's going to cancel the power of 2. The square root of 13 is 3.6. Your foci always goes with the vertices, so I'm going to add and subtract it to the x value. So let's go ahead and find those 2 points. 1 plus 3.6 is 4.6. You keep the y the same. 1 minus 3.6 is -2.6, and you keep the y the same. So if I go to the right 4 and a little bit and down 2, it is not inside the box. This is your vertice or your vertex for that branch. You go ahead and make sure that the focus point is inside of the branches and you use the asymptotes to see how wide. Now -2.6, go down to, again, it's outside of the box. Go ahead and hug that focus. So this was the review for the hyperbola. Backside, you guys, and we're done. Typically in the past, the parabola was the one that was kind of a stinker for a lot of people. So you will notice that we will do 3 questions pertaining to the parabola, okay? On your cheat sheet, vertical parabola, that's when the x is squared. If the x is squared, your parabola opens up or down. Horizontal parabola, that's if the y is squared. If the y is squared, it has to open to the left or the right. Now here, the y is squared. If the y is squared, it's horizontal. Okay, the vertex. The vertex, here is my equation. We're looking at a horizontal parabola, so in parentheses, what are you subtracting from x and y? Well, this first one, I'm not subtracting anything from x and y in parentheses. So my center, or not the center, sorry, the vertex is at 0, 0. Now p. When you look at the formula, in front of the variable that is not squared, it says it's 4 times p. Well, in our case, 4 times p equals -12. So if I divide both sides by 4, I will find that p equals -3. Now, the reason why I need to know this is because this is how I find the focus and the directrix. It's horizontal. So to find the focus, I have to take x plus p. To find the directrix, I take x minus p. So I'm taking, the focus is a point. So I'm taking the center, the x value plus p, 0 plus a -3 is a -3, keep the y the same. So I go to the left 3, stay at 0. Now your directrix, it has to cut the x-axis, so its x equals, your x value was a 0, minus a -3. So if you picture this, 0 minus a -3. minus a negative, you're actually adding, you guys. So this is x equals 3. So my directrix is a line that is cutting the x-axis at a value of 3. Now the parabola is the one where we did not get into it enough to know exactly the width. So what you need to do is just make sure you use the vertex. The vertex is the point in between the focus and the directrix, and you draw a branch that hugs around the focus. However wide you make this, totally fine, as long as the directrix is behind and the focus is inside the branches, you're golden. Okay, let's look at 2 more of these. Now here's the deal. When you look at the formulas for parabola, only one variable has a power of 2. Whatever has a power of 2, that needs to be isolated on just the one side. Okay, so I'm going to go ahead and I'm going to move this. I want this power of 2 all by itself. And notice in these equations, this is why I had you do this cheat sheet. I don't want a number in front of here, okay? But one step at a time. I'm going to go ahead and take this over here. So it's 6 outside of x plus 1 squared equals, this is a plus 12. So I'm going to minus the 12 times y minus 3. This is a parabola. I know that because it only has one power of 2. From the equation, I know that I just want my squared value on the left. I cannot have the number out front, so I need to divide both sides by 6. Here is your equation. X plus 1 quantity squared equals negative 12 divided by 6 is a negative 2, y minus 3. So I did have to rearrange that in order to fit, okay? Now we want to know, is this vertical or horizontal? In order to do that, you have to look and see where the power of 2 is, which variable is squared. Here, the x is squared. If the x is squared, it's a vertical parabola. That means that it has to open up or down. Your vertex, what are you subtracting from x? Negative 1. What are you subtracting from y? 3. So the vertex is negative 1 up 3. Now P, the value that's on the other side of the equation as the power of 2. It's 4P equals, in our case, it's a negative 2. If I divide both sides by 4, P is negative 2 over 4, which is a negative 1/2. Now to find the focus, because it's vertical, you take the y value plus P, the directrix, y equals y minus P will be a line that's going to cut through the y-axis. Okay, so I'm going to take the vertex, take the y value and add P. So it's negative 1, 3 plus a negative 2, 3 plus a negative 1/2 is a 2.5. I'm just minusing 1/2. So I go to the left one up 2.5. Okay, so your focus is right there. So right now, you guys, if you wanted to, you could do this. Okay, mine was not very centered, sorry about that. But I have my vertex and I have the focus underneath. I can see that it's opening down. Now to find the directrix, it's y equals, the y value is 3 minus a negative 1/2. If you minus a negative, you're actually adding, so it's 3.5. So I go up half a unit and I cut the y-axis. So again, the vertex has to be in between the directrix, which is a dotted line, and the focus, which is inside of the branches. It's vertical, that's why it's opening either up or down. This was a negative value, that's why it's down. Here, again, this was horizontal, it has to open left or right. P was a negative value, so it opens the negative direction, which is left. Let's look at one more. Now this time the equation is ready for you. X has the power of 2. Whatever has the power of 2, that helps you indicate if it's vertical or horizontal. It's x that's squared, so it's vertical. So this parabola will open up or down. Your vertex, I keep wanting to call it center, sorry guys. Your vertex, what are you subtracting from x? Negative 2. What are you subtracting from y? Negative 2. So it's left 2, down 2. P, you take 4P equals whatever value is in front of the set of parentheses on the side opposite of the power of 2. So in this case, it's a negative 8. If I divide by 4, then I can solve for P. Negative 8 divided by 4 is a negative 2. This is negative. So that means it's going to open vertically in the negative direction. So again, it will be opening downwards. Vertical, so it's y plus p. Directrix is y equals y minus p. This will be a line. This will be a point. So to get the point, I keep the x the same. It's a -2. Now I take the y value, -2 plus a -2. -2 plus -2 is -4. So left 2, down 4. And if you want to, right now you could say hug the focus. Okay? You could do that, no problem. Now directrix, it's y equals the y value, -2 minus a -2. Well, if you minus a negative, that becomes a plus. -2 plus 2 is 0. So I cut the y-axis at 0. There's my directrix. So this is a really good review for parabolas. And typically, like I said in the past, this was kind of the section where classes kind of struggled the most. Now, the last idea, this was something that came up in every single section. If they gave you what's called the general form of the conic section, you had to do what's called completing the square. Okay, and that's a skill that we covered at the beginning of the year. Can you complete the square and go ahead and figure out what the conic section is? And so that's what we're going to do for 10, 11, and 12. And then you guys, you're ready to take this test and finish pre-calc. Number 10, right now I can tell you this is a parabola. The reason why is because I only have one variable that is squared. The circle has both x and y squared. The ellipse has both x and y squared. Also, the hyperbola has both x and y squared. The parabola is the only conic section that only has one power of 2. So what I'm going to do is take my x squared plus 6x. I know I'm going to have to go ahead and complete the square. These two things are going to go to the other side. So minus 8y minus 1. I can complete the square here because there's not a number in front of my square term. So I take b, 6 divided by 2, it's 3. 3 squared is 9. If I add 9 here, I also have to add 9 here. So this is -8y plus 8. I can factor this. That's what completing the square allows us to do. Two numbers that are the same number that multiply to 9 and add to 6, well, that's 3 and 3. So this is x plus 3 squared equals. Now, you do not want a number in front of your y. If you go ahead and look at my parabolas, I can have y minus a value in parentheses, but I do need whatever they have in common to come out. So I'm going to go ahead and take out the -8. So if I have -8, that cancels that cancels that. So y. Positive divided by a negative is a negative. 8 divided by 8 is 1. So here is my final equation. X plus 3 quantity squared equals -8 y minus 1. This is a parabola. It's going to be vertical because the x value is squared. It's going to open downwards because this is a negative value. Your vertex is at -3, +1. So look at all the cool things you can determine by that. Let's look at number 9. Now, number 9, I know it's not a parabola. The reason why I know it's not a parabola is because the y is squared and the x is squared. So I'm going to go ahead and 9y squared minus 18y plus we don't know yet. I'm just taking the y's for right now. We might end up moving it to the back, but we'll see. So the 9y squared and the 18y, I put them together because that way I could complete the square with the y's. Plus, now I group the x's together. -4x squared plus 24x plus, we're going to complete the square, so I left room to do that, equals my -63 does not contain a variable, so I'm going to add it to the other side. Now, before you complete the square, you have to make sure that your leading coefficient is a 1. So in this first set of parentheses, I need to divide out a 9. So 9 comes out, giving me y squared minus 2y plus we don't know yet. Now here, this needs to be a 1. So I'm going to divide out a -4 from the second group. Negative cancels a negative, 4 cancels a 4, so this is +x squared. Positive divided by a negative is a negative. 24 divided by 4 is 6x, plus we don't know yet, equals 63. Now we can complete the square. So you take the number in front of the letter. -2 divided by 2, that's -1. -1 squared. -1 times -1 is 1. Remember, this 9 also goes with the 1. So 9 times 1 is 9. So to keep it balanced, you have to add 9 over here. Now I'm going to complete the square here. -6 divided by 2 is -3. -3 squared is 9. This -4 goes with the 9. So -4 times +9 is -36. So I do need to minus 36 over here to keep it balanced. Now what I can do is go ahead and factor these. So I have a 9 out front, two numbers that are the same number that multiply to 1 and add to a -2. Well, that's -1. Minus 4, factor two numbers that multiply to 9 and add to -6. Well, that's -3 and -3. This needs to become one number. So 63 plus 9 minus 36, what you get when you do that is 36. Okay, so right now I know it's going to be a hyperbola. I know that because I have two groups. The y is squared, the x is squared, and there's a minus in between. Both the circle and the ellipse have to have a plus in between. We have a minus, so it's hyperbola. But the rule with the hyperbola is it must be equal to 1. So I need to go ahead and divide every single group by 36. 9 over 36 can reduce to 1/4. So I'd have y minus 1 quantity squared over 4. 4 divided by 36, this can be reduced to 1/9. So it's x minus 3 squared over 9 equals 1. This is a hyperbola. It would be a vertical hyperbola because that's the first variable that we have. Your center would be at 3 and 1. A would be 2. B would be 3. So again, you can find out a lot of information by going ahead and just converting it from the general form to the standard form. Last question, you guys, and we are done with all of the notes that you ever will have for pre-calc. Yes. Okay, this one again. So number 12, when I look, I notice right away it cannot be a parabola. The parabola is taken off the table because both the x and the y are squared. I do know that what I need to do is complete the square. So I'm going to group the x's together, group the y's together. So x squared minus 6x plus, we don't know yet, plus -4y squared minus 16y plus, we don't know yet. Any variable that, or any number that does not have a variable needs to be moved to the other side. So I'm going to, sorry about that, I'm going to take this -11 and I'm going to move it to the other side. Because it's negative here, I had to add it. Now, you cannot complete the square if there's a leading coefficient other than 1. This group is fine because this is a 1. Not so much here. I need to divide out that -4. So x squared minus 6x plus, we don't know yet. Take out the -4. Negative cancels negative, 4 cancels a 4, so I have y squared. Negative divided by a negative is a positive. 16 divided by 4 is 4. Y equals, this side is 11. Now we can complete the square. You take the number in front of x, divide it by 2 and square it. -6 divided by 2 is -3. -3 squared is 9. So I need to add 9 to this side. Complete the square. 4 divided by 2 is 2. 2 squared is 4. But this is -4 times 4, so it has a value of -16. Now I can factor two numbers that are the same number that multiply to 9 and add to -6, -3 and -3. -4. So right now, you guys, I know it's a hyperbola. It's the only option that has a minus in between. Two numbers that multiply to 4 and add to 4, well, that's 2 and 2. Equals 11 plus 9 minus 16 is 4. With the hyperbola, it has to equal 1, so I need to divide everything by 4. So here is my final equation for our final question of the review. X minus 3 quantity squared over 4 minus 4 over 4 cancels. Y plus 2 quantity squared over 1 equals 1. This is a hyperbola because it's two fractions with a minus in between. It's equal to 1. This is a horizontal hyperbola because the x comes first. A, the square root of 4 is 2. B, the square root of 1 is 1. The center of your hyperbola would be 3 and negative 2. So again, lots of information. You guys, once you take that conics test tomorrow, you are done with pre-calc. I hope you have an amazing summer, and I'm proud of you for the way that you have handled distance learning. You did it. Give yourselves a pat on the back. I hope to talk to you all soon. Bye.